Hello, I'm audible.
Yes.
The screen is visible, right?
Yes.
Okay. So, is your project done?
Yeah, I did it, but it's not working. Maybe there are like
All
some
working?
parts. No, it's not.
Actually, I have contacted one of my Python developer, and he will be available tomorrow or maybe day after tomorrow, and he will arrange a meeting with him, and we can explain what is your requirement related to your project. Okay, and
Okay.
if you find whether what what is an expected project you want to do and he's able to build it, then we can take it further. Okay.
Okay. Mhm.
Mm. As of today, we are starting with binary search tree, and before going ahead we need to know, okay, what are the basic concept of the binary search tree. So as we have already learned in previous session, binary search, do you remember binary search, the basic concept of it?
Yes.
Exactly. So, suppose you are given with this, uh, you must have already studied the basic stuff like this. About these other countries you have mentioned available here: USA, India. What is the basic stuff? Basic in Python, what we call this thing? What will be the output for this? It's actually a list, right?
Oh, yes. Mhm.
This is a list in Python. And if you see carefully, I think we have duplicate values here, right? So this
Yes.
is the duplicate value, this is the duplicate value. And list will actually going to print as it is. So it will print in a similar way, whatever you have given the input. So there is no uniqueness to it. So you will be getting exactly same output. But in contrast to this, we have something called countries. Let me make a variable country set. You must have studied set, right? So if you want to create set, what we do, we just write like this, right? But inside this, we pass a list. So when we are passing the same list, so what is an expected output for this?
For the set, I think there can be duplicate values.
Exactly, very good. So what it will do, it will print me a unique value. So there won't be any duplicate value for it. And there is also no fixed order, so that it will be written in a specific order. It will be exactly same. No, it will not be. It will vary at different instance of time. Okay, so here what we are getting different value, and it is also unique, but not same value which is getting repeated here. Okay. Similarly, in binary tree, we we need so have a same concept where we need to build a binary tree where you let's see how we build a binary tree. Let's take a small basic concept. Whenever we create a binary tree, we will be creating a node. It will be having three things. First, second, here you will be having a left address. Here we will be having a data or value inside it, and here you will be having a right node address. Okay, so basically this is known as node, which we can write like this also, just like this. We can keep on creating trees. So here it is a binary tree. So every node shall have maximum 2 nodes, not more than 2 nodes. Okay. If you create one more node here, it will be no longer a binary tree. It will be a general tree. So at this point of time, this is my general tree. But as soon as I remove this, now it is a binary tree. Even if I create one more node here, it's a binary tree. Okay, makes
Okay,
sense.
yes. Mm-hmm.
Okay, so if you want to create a binary tree, let us create a binary tree and see how we need to create it, because we will be doing the program for the same thing. So suppose you are given a value 17, 4, 1, 20, 9, 23, 18, 34. This is the list you have got, and you need to create a binary tree for this. Okay. So which number will be the root node here? Can you tell me?
How about the binary search tree? The
Yes,
17 will be placed
exactly.
as
The
the node.
first index value, which is the index location 0, will be considered as a root node. Very good, excellent. So 17 will be my first node. So what we will be doing for the index location 1? What is the rule for this?
On the lesser value, the lesser value will be placed on the left.
Exactly, very good. So that is the basic rule applies here. Your root node is here. Okay, I'm denoting the root node with n. There is a reason behind I'm using n here, because I will be creating a formula for that. And here at the left side, you will be having a smaller value, and at the right side, it's here in the right side, you will be having a bigger value. Make sense now? So considering this rule, we will be inserting a new node. We will be visiting our root node 17, and we'll check whether there is anything at the left side previously stored, or nothing is there in the left side. So as of now, there is nothing at the left side of the root node, and neither there is on the right side of the root node. So I will be inserting, since 4 is smaller, I will be inserting 4 here. So we have visited index 1. Now at index 2. So tell me where I should insert index 2 value. That is 1.
To the right of 4.
Right of the 4. Sure.
Oh no, sorry, left of 4. Small value. Sorry.
Exactly. 1 is less than 17. It is also less than 4. That's why I will place it at 1. Here to the left of the 4. Okay. Now we'll work on index 3. Value of index 3 is greater than 17. I'll visit my root node. There is nothing available in my right side of the 17 root node. So I will be inserting 20 here. Okay, I will be adding 20 here. Now for the index 4. So what should be done here? Where it will come?
9 is less than 17, but it's
It is
great.
less than 17. Good. It is greater
Greater
than
than.
4. Exactly. Excellent. So here we'll be adding 9 to the right of the root node 4. Now for index 5. So 23
is greater than 17 and
it's greater than 17, correct? It's
greater
also
than
greater than 20.
23.
Exactly. So here we will be getting 29. So what about 6? Index 6 value?
It's greater than 17, but it's
It's greater than 17 but less than 20, right?
yes.
So 18 will be here. So now for the last index, index 7,
It's greater than 17. It's also
greater
greater
than
than
17, greater than 20. Okay,
and also greater than 23.
exactly. Very good. So here will be your 34. So this is what an expected to be a binary tree. Okay. So let me give you this one number here. 50, 25, 21, 52, 7, 14, 72, 82, 63. I want you to make this binary tree for this.
Okay. $50 will be the root node.
Okay, 50 will be the root node.
And then
Mm,
25 is less than 50, so it will be on the left.
Okay, 25 will be here.
And then 21 is less than 50, and it's also less than 25. So it will be to the left of 25.
Okay,
And then 52 is greater than 50. So it will be to the right of 50.
okay,
And 7 is less than 50. It's also less than 25, and it's also less than 21. So it will be to the left of 21.
okay,
And then 14 is less than 50. It's less than 25, and it's less than 21. But there's okay, so it will so it'll be to the right of 7. It's greater than 7.
okay, correct. Yeah,
72 is greater than 50, greater than 52.
mhm,
So it will be to the right of 52.
okay,
82 is greater than 50, greater than 52, greater than 72. So it will be to the right of 72.
okay, good, very good.
And then 63 will be greater than 50, 52, and 72. And then it's less than 72, right? The left of 72.
Right of 72 or left of 72.
Right.
Right is already occupied with 82.
Oh, sorry, left. Because it's less than.
Exactly. So this is the expected answer. Okay.
Yes.
So one more question I'm giving to you. Just I want you to write that on the paper.
Okay.
Try this one. Do it on the paper.
Okay. Yes.
Okay, done.
Yes.
Share me the screenshot of photo of it on WhatsApp.
Okay.
Uh, s- 17 you have put on the center. Left there is 3. To the right of 3 is 7. To the right of here it is going wrong. 8 is bigger than 7, right?
Oh, okay. Yes. 13.
See here, 17 here.
So 8 will
And
go in the ninth place,
exactly.
and then 9 will
See here,
go to the right of
right of the 8.
8. And then 18 will go to the. Okay, yes, that's.
Done.
Yeah. Which one?
Let me this same one.
Yeah, I sent it to you.
The new one you have sent me. Okay, let me check. See, I'm making here. Whether it's going, see. To the right, to the left, it will be 3. Then 7 will come to the right. Okay. 8 will come to its right. 9 will be to its right. Okay. 18 is bigger than 17, then it will be here. 14 is less than 17, greater than 3, greater than 7, greater than 8, greater than 9. Right? So it should be right here. I think you have done. Okay, 14 is at
Oh,
wrong place.
okay, I forgot to add the 14.
See, 14 is missing actually.
Yeah, I forgot to add.
Mhm. Look at here. We can make the correction later. 52, right? 52 is greater than 17, greater than 18, so then it will be to the right of the 18, 52. Now 63. 63 again here. It's less than here, 55, and it's greater here, 88. Okay,
Yes.
so your answer was correct. I think only 14 is missing in this side, second one.
Yeah.
Okay, let's go ahead. Mm, Suppose you are given with a tree. Now, before going ahead, let me explain you this thing. BST is of two types. First one is breadth first search, and second one is depth first search, which is popularly known as DFS. And this one is also known as BFS. But this again is of three types: in order, traversal, pre-order, traversal, and post-order traversal. Okay, traversal basic meaning is this thing what we did here, traveling through the tree. Means when you travel through the tree is known as traversal. Okay, and as I said, it's of two type: breadth first search and depth first search. Depth first search is again of three type: in order, pre-order, and post-order. So consider we are given with a tree here with 12 here, so it's here 7, here we have 14, here we have 27, we have 20, and here we have 88, and here we have 23. Okay, so we have been asked to create in order for this. So in order, the basic formula for in order will be put the root node at the between, consider the root node as n. Whatever should be there on the left side should be this thing, and on the right side should be this thing. Okay, so what I do usually, I create a formula like this. Formula should be here in order. In matlab, in means inside, right? Somewhere between it. So it is between your left and right. Consider this. In means it is inside your left and right. Pre means before, coming before the left and right. So your root node should be this n is your root node. Okay. So n should come before your left and right. Similarly, post, here post we have. So left, right we have here, but root node should come afterwards. So got the formula?
Yes.
So here we should remember always whenever we are writing, your n should be in between. Your root node should come first in pre-order case. Your post in post-order case, your root node should be at the end. Okay. Based on this formula, we will be creating a traversal for this tree, which we have done here. So, which is the root node?
15.
Exactly. See, when we are making a tree here, we should always make sure if we identify the tree and subtree. Consider this to be a root node. So this everything here is considered to be at left side, and this should be considered to be at right side. Okay. But when we move further, okay, if we consider this to be root, so this will be my left node, and this will be my right node when I am working on my subtree, this thing. Okay, but when I'm working on another subtree at this side, at the right side here, this one, Suppose I'm working on my subtree this. So let me consider this to be the root node. And to for that root node, this is at the left side and this is at the right side. Okay. And similarly, we keep on solving, considering a root node at each time and considering left and right at each time. So now, if I consider this to be my root node, sorry, subtree, then this will be my root node. Okay. And anything, whatever there here will be considered as left. Anything here, whatever is there here will be considered as right. So far clear? Make sense?
Yes.
Let me solve this. Just what I have done this is just an imagination what you will be doing. But to make that more simplified way, we can do this like this. As I said, your root node is at the between here. Okay. So your root node is at the between and everything will be on left and everything here will be on right. So what is the root node in this case? I have 15 here. Okay. Getting my point here? So now I have to work on this part and this part separately. So let us take this as my subtree. Again, for this one, here in this case, are you able to see my mouse pointer?
Yes.
I'm finding difficult with it.
No, I can see.
Okay, just a minute. Wait a minute. It's very small. It is. The screen visible now?
Yes.
Okay. Now you can see the yellow circle around it, right?
Yes.
Okay. Going ahead. Now, as I have to focus on this subtree, so this is my root node. So I would be putting my root node 12 here, and everything will be here to its left and here to its right. Okay. On similar way, I would be going for 27 as root node here. Everything for it will be a left and here it will be right. So again, N, L, R, N, L, R, right? So to the left of the 12, I have 7 here. To the right of the 12, I have got 14 here. And in this 27 case, to the left, actually, I have a bigger subtree. So I need to consider 20 as root node and I have to create its left and its right. And to the right of those 27, I have only one node available. So directly we can write 88. And now to solve this subtree here, this one, there is nothing on the left, so it will remain empty here. There will be nothing coming up here, but here will be 23. So finally, what I get here is 7, 12, 14, 15, 20, 23, 27, 88. So this is actually my in order traversal for this particular tree. Understood how did I created this in order traversal?
Yeah.
Or any confusion you have got?
No, it makes sense looking at it.
Okay. It's self-explanatory right now, exactly, with using formulas.
Yes.
Okay, I want you to create this now on your paper. I'm grabbing it for you. Same thing, same, exactly same answer I'm expecting now. Use the formula LNR. Share me the output on WhatsApp.
I think I'm a little confused again.
You got confused?
Yeah.
Let me explain your way. See, whenever you are taking this as a tree, consider any tree you are getting. Just make overview that you have got root node at the between, and left will be at left and right will be at right. That makes sense, right? Left will be always at the left side of the root node, and right will be always will be the right side of the root node. So in this whole tree, when I'm visualizing this as, I should visualize it as a whole tree right now. So this will become my root node, right? So I should put exactly in the between somewhere here. So here will be my n, and everything whatever I'm going to get, as I am expecting there is a big subtree here, and there's a big subtree as well as here. So I'm making a big long line here. So this will be my left part of my root node, and this will be all my right part of the root node. Okay, so this is my left part, and this is going to be my right part. Now, see, whenever you are solving this such kind of problem, do it very patiently, because if you go on haste, if you're going to run on solving the answers, we may commit a mistake. Now, as we have solved it, to make sure the what was there at the left of it. The left of it was the 12. Exactly. So put the 12 in between this line. What was there at the right side of the 15? 27. Again, put 27 at the right there. Is it visible to you? Am I writing very small?
No, I can see it.
Okay. Now 12 and 27 is done. Again, 12 is also my root node and 27 is also my root node. Exactly. Because if you see, I can, for this subtree, this is the root node. For this subtree, this is the root node. See, in tree, everything is root. Make that. Everything is root. If it gets left or right. Okay. So now for this, we have 12 as a root node, and this we have 27 as root node. Now, as I know, 12 is my root node for this subtree. So there is something over it over the left, and there is something over its right. So I should make again a line here and again a line. Again left and right. Okay. Make sense?
Yes.
Now, if I consider this to be a subtree, there is no left right now. So no need to go ahead, is a leaf node, right? It's a leaf node. Leaf node means where a node does not have any further child node. Okay, the basic concept. If the root any node which does not have any further child node is known as leaf node. So 7 a leaf node. So I will not be making this thing lines here for 7, because 7 was my leaf. No, in same toward the right of 12, I have 14. So I'm going to put 14 here. Now come to this side. As I know, again, it's a big subtree. So there must be something of the left of 27. There must be some numbers toward the right of the 27. So I have created this line. So left and right. Now to the left, I have 20 and 23. Two numbers are there. So again, it's a subtree, right? So I need to visualize it. Again, it's a little big, so I will be doing it later. Let's solve this one because it's a single number and there is no subtree. So directly I can put 88 here because it's a leaf node. Now I need to solve this. When I'm solving this, I know that for this subtree, I need to consider this as a root, and there is no left node here. Okay. So taking this, considering that, again, I need to write exactly in between this line, between this line. Okay. So there is nothing on the left, but there is something on the right. That is 23. Here I got my answer. 7, 12, 14, 15, 20, 23, 27, 88. Got understood?
Yeah, I understand.
Or still confused?
No, I understand.
Okay, great. Let's go ahead and we'll try for pre-order. In case of pre-order, the formula will change. Pre means first, right? Before. So my root node will come first. Later, I would be taking up left and right. So my root node is at the beginning. Okay. So here in case what I did when we were making root node here, we went 15 here, right? At the between of my left and right. The root node was exactly in between of the left and right. On similar way, I would be taking root node 15 at the beginning, and everything will be somewhere here left, and everything here will be to the right. Okay. So here it will be left, and here it will be right. Clear?
Yes.
Okay. Now, when I'm solving this part, again, I have to consider this to be a root node. And since it is a root node, because of this formula, I will be writing my 12 at the beginning. 12 will come here, and 12 will have a left and right. Left and right. And when you're solving this subnode, we'll consider this to be the root. So at for this line, which you have written here 7 for the right side, at the beginning you will be writing 27 here. And it's since it's a root node, it will have its own left and right. See, it's following the full formula here. N, N, L, R. And for this subtree, NLR. And this for this subtree, NLR. So if you can see, there is actually a recursion going on here. NLR is keep on repeating itself. Okay. So now, as we have solved this thing, now we need to go further in this part. So there is nothing to the 7 to the right and left to the of the 7. There is nothing on the left and right of the 14. So for 12, considering 12 to be my root node, I would be putting up 7 here and 14 here. So this part is solved. Now let us go to this thing. Now to the left, I have 20. So again, 20 is having a subtree actually. So I will be putting 20 at the beginning because 20 itself is a root node for this subtree, and it will be have a left and right. And 27, there is nothing, just only 88 here. It's just a leaf node. Directly I can write this. Okay. Now 20 is the root node. There is nothing on the left, and it is there and something on the right. So this line I will be not writing anything here, but I will be writing on this line. So it will be 23. If I write it properly, now the answer would be 15, 12, 7, 14, 27, 20, 23, 88. 12, 15, 12, 7, 14, 27, 20, 23, 18. So this is my final answer for pre-order. Any confusion? Or should I repeat it?
No, it makes sense. Yeah.
Should I repeat this? Okay.
So this one, okay.
What queries we have?
For this one, it will be the root node, and the left node, and the right node. And then if
Yes.
there's any, the root node has any children.
Subtrees.
Okay, subtree.
Then it will be again root node, left node, and right node. So this thing is going to keep on repeating.
Okay.
So okay, let's go ahead and try for pre-order. Post order, sorry. Post order. Post means end, at the end, at the last. Okay. So at the last, I will be putting end, and before that, there will be left and right. So the last root node is coming at the end. If you see carefully, here my root node was in between, and my root node was the beginning, and it applies for all the subtrees exactly. And for this, my root node will actually be at the end here because I'm putting n here at the last. So this everything will be at this part, left, right, left side nodes, and here will be my right side nodes. Got? Understood this part? Basic formula.
Yes.
Okay. Now for this line, again create left and right, and this will be left, right, and my root node will be here. For this following line, create left, right, and root node here. Okay. For 15, you have this subtree, and this is my root node. Put this here. And for at the right side, this one, this is going to be my root node, right? Put this here. Make sense?
Yes.
Okay. As I have done with 12, 27 here. Now, for this left part, again create this thing. Left, right, root node. Okay? Left, right, root node. So as I don't have any subtree here, I can directly, without doing this also, I can put here 7 here and 14. Okay.
Oh, okay.
Now here in left side again I can create left, right, and root node. It's left, right, and root node. Here left, right, and root node. Left, right, and root node. So in this scenario, if this was a root node, everything here will be, this part will be at left and this part will be at right. Right? Now, if I consider this subtree now, this is going to be my root node. So put this here. And I don't have anything here to keep this as empty. And right will be 23 here. Okay. Now for 27, this is subtree and it is at the right side. Just put it like this. So now 7, 14, 12, 23, 20, 28, and 27 and 50. So this is my post order traversal. Okay, it's a little difficult at the first time, but if you get in habit of writing the formulas, you will be get accustomed to it. See, for in order, what you do, if you have in order to solve, put the root node at between, everything at the left and right. For this thing, again, put the root node at the between left and right. Put the root node at the between left and right. So keep on doing this thing. Again, for this thing, put the root node at between left and right. Put root node on between left and right. If for this thing, put the root node at between left and right, and with root node between. So you have to keep on doing this thing. If you get and have practice of this, you will be getting it. Now, in case of reorder, you can do the same thing. Root node, small dash, left node, big one, right node, big one, right? Root node, left, right. Now for left, again you can put root node at the small dash, left node, right node means left and right. And here also left and right. Getting the visuals how you can relate it to it.
Yes.
Or you're finding it difficult?
No, this way it seems a bit easier, but I think I need more practice.
Yes, yes. Just if you get a habit of solving in this way, probably will not going to make any mistakes. Okay,
Yes.
just try it for this thing on your paper.
For which one? Post
The
which one? Oh,
same
okay.
trick. Start from pre-order. You already made that attempt for in order, right? Try for this one pre-order. What you do? Just listen here. For pre-order, it in the beginning the formula is what? N, L, and R, right? Make a small dash for N, big dash for L, and big line for R. And this here, small dash, big line here, big line here. Small dash, big line here, big line here. Again for this thing, same like. So start making like this, then only go ahead. Okay.
Okay. Okay. Yes.
Done.
Yes, I'm done.
Getting the same answer as this here.
It was
Can you share me the photo?
okay. So like for the third like to the right of 20 there's 20 to the right of 20 there's 23, right? So like
Yes.
that level, how do I'll show you that.
Just share me the photo first. Let me see what you have done. Hmm, 15, 12, 7, 14, 27. Okay, you missed. I think you missed for 25. I cannot see 25 anywhere. See, once again, I'm showing you here. I think I need to delete that itself. You have missed one number, right?
Yes.
See, what you can do, make a small dash for root node, big dash line for the left, and big line for right part. Okay, so here we got the formula NLR. 15 will be here. Okay, as since my left is having a subtree, okay, left will be having a subtree. So again, I will be repeating this formula here, NLR. Okay, so N, L, and R. For again, right will be having my subtrees. So putting N here, L, and R. So here will be 12. Root node is 12, right? For this case. And to the left of what 12, I have 7. And to the right, I have 40. So this was all easy, right? But
Yes.
only thing you got, yeah. So this was root node, this was left, and this right. But left was having a further subtree. So you can again have to write like this, left and right. Okay.
Mm,
Small dash for root node, left and right. N, L, R. So in this case, here 27 I need to put here. And to the right, I have 88. Okay. What about this part? So if I see, I have encircled this, right? So don't have anything here. I don't have anything to the left of it. So this is going to be 20 without a doubt. Left, I will remain empty. And to the right, I will be putting 23. So this is going to be like this. So 15, 12, 7, 14, 27, 20. Left is nothing here. 23 for the right one and 88 for the left. Getting?
yes. Makes sense.
Try for this one. So your post order.
Okay.
Done?
Yeah.
If done, share me the photo.
Okay.
See what mistakes you are committing while creating those lines is actually. Am I audible?
Yes.
Okay. See, whenever you're creating a line, follow the order of. See, when you're creating line for left, it should be a big line, right? And right should be always be a big line. For root node, make a small line like this. Now, if you see, I can directly put 15 here. I cannot find 15 in your screenshot or photo you have sent me. So you have got 15 here actually. Now again I have to create that particular big line and small line for root node. Here also again big line, small line for root node. Here in the root node area, which there is a small line, I have to put my this root and this root, 12 and 27, like this.
Okay.
When you're following this thing, the properly line, if you create the proper order, then definitely you will be getting a correct answer. Your order of creating those lines should be clear. This is the rough work we are doing. Final expected answer is this thing only. Okay, but if you're solving this numerical, we should follow this order. Now for 12, there is no subtree. I can put up directly 7 here and 14 here. See, what happens, I feel like I have 12, I have 12 here, let me write this and like this will not, this will create a problem in future if you got some more subtrees here. Okay, this tree is actually quite small. There may happen a case in examination or in any when you're solving a traversal problem. A tree will be, maybe you will get in a big tree. Okay, so follow the same rule. Your left should be a big line, and the root node should be a small dash.
Okay.
Clear?
Yes, I
If
see.
you follow this way of style of writing, probably will not be getting any mistakes. Again, for this, if this is left and right, again create a big line. Small comparatively with your root node should be small, bigger, right? Left and right. Similarly, root node here big like this. For 12, at the left of the 12, I have 7 here. To the right, I have 14. I'm putting 14 here. So it was N, L, and R. Now, for this left part, I have 20 here. And for this part, I have 88 here. And for 20, I don't have further. There's nothing on the left. So don't put anything here. Keep it empty. But I have 23 at the right side. Put like that. Hence it is solved now. Okay. Make the lines properly. If you're making the lines properly for left, it should be big enough. Right will be a big enough line, and root node should be small. Comparing to your root node, this line should be big.
Okay.
Okay. So similarly like this. So you're following the post order in case of post order, where we have to put the root node at the last, right? Then left and right. You are following this thing, definitely you will be getting correct answer. Try to practice it. Okay.
Okay.
Okay, let's go ahead and as we have already practiced of creating a tree, how we know how to create a binary search tree traversals. Let's go ahead and create a program for that. So what we need to do in this case, when we are creating, suppose there are cases available. We have case 1, case 2, and case 3. Here I have a binary tree. Can you see? I have a binary tree.
Yes.
Is there any binary tree?
Oh, sorry. No.
No, there is not no binary tree here. See, simple case. In case 3, I have A node. To the left, I have B, and to the right, I have C. Okay, or else we can say 17 I have here, and 8 here, and 19 here. Okay, this is the case where I have at least a binary tree with two nodes. I have a case here where I have only root node, nothing on the left, nothing on the right. This is one case. Another case where I don't have binary tree at all. It's an empty tree actually. This was actually I was asking to you. What the
Okay.
cases, different cases?
Yes.
Okay. Based on this, I have to take into consideration while developing the code where I have a proper binary tree where I have only root node available with me. I have to decide before putting my adding some values to the left or to the right. Okay, and I don't have at all any tree created so far. And I have also further case 4 where I have 17, to the left there is 8, to the right there is 19, and I have to add more tree node to the left of 8 or to the right of 8 or maybe to the left of 19, the right of 19. This can be another case. So based on this all four cases, we considering all these four cases, I need to create a code for that. So considering this case where I have only one node, root node, so I need to create a data type where my node will have three things. If you remember at the beginning, I said nodes usually can be created like this, where the between part will be containing data and whatever there in the left will be, uh, suppose here we have 17. Here we have a left address value of the left side node. We have right address of the right side node. Okay. But for this case too, I don't have anything on the left or neither I have anything on the right. So this will be null, right? This will be null, or you can say none. Make sense? For this case two.
Yes.
Okay. So let me create the code for that. We'll be creating a class. Code will be very big, huh? So and you will be falling short of spaces. Let me and I'll name my class as binary search tree, and I'm going to create a node here. Here in binary search tree, I'm going to construct my this thing, this node, where at the center I will be having data, and to the left I will be having nothing, and to the right I will be having nothing. Okay, for the case one, case two, I think. Yes, this case two. So let's go ahead. I will be creating constructor initializer now. Init. Here we will be having a construct initializer with self. I will be passing some data from main part. So let that will be data. This is the same thing here I have written. This data. Okay. And self dot data. This data is equal to the data which will I will be receiving from here. That will be the data here. Okay. And to the self dot left, don't have anything, so I'm putting up none here. Okay. So in self dot right, I don't have anything. I will be putting it none here. Make sense? This thing is exactly this thing.
Yes.
Any doubt?
No.
Okay. So when I want to create this root node into the RAM memory computer with specifying some specific values like this, Suppose I want to pass 5 year. Okay. What I have to do? Okay, let me write this thing. Is okay, yeah. Okay. So I will be calling up this class constructor by writing like this binary search tree node, and to the constructor I will be passing this file. So what will happen? This will call this. Your file will be passed here. It will be passed here. Then it will pass here, and finally this node will be created, which is actually this one. Okay. So this is as of now a root node because it's the first node of my binary tree. Let me make put this give this name as a variable root node. Make sense now?
Yes. So what's the name if name equals main?
Here actually we are running a main function from here to run this class. Okay.
Okay.
Now what I have to do, I have to add a new number to the left of my this root node 5, and I have to also add one more node to the right of this 5. Okay, I need to add something, right? So adding is again a task. So I can do, I'm let me create a function for that. Def add a child node for that. Let me name it as a child, and like this. And so when I need to call up this right from here using this root. So root dot calling this function as I created the object for this. For with that function, I can add a child to it, and let that child will be 2. Okay, so it will be coming up here. But how do I know whether it's going to create the same structure just like this? No, right? So that need to be done. So consider this thing. We are adding some 2 here, and let me add one more root, one more child to the left side, right side. Here at D9.
How about the
Okay,
root node?
this one.
Yeah. Is there like a function to add the root node, or is it like already?
I have not created actually that till now.
Oh,
Just I'm actually creating pseudo codes right now. Actually, what
okay.
before adding this line at child 2, we need to check actually it's 2 is smaller than 5 or not, right? That's the question you are asking me.
Oh, okay.
For that thing, I need to do this thing here on this particular function itself. Okay, so when I'm adding 9 to my uh, root node, again it should check whether the 9 is greater than 5 or less than 5. If it's greater, then it should be at the right side, right? So what I do, let me open VS Code. Screen is visible.
Yes.
Mhm. Okay, what I did, I just created a class here with a name binary search tree node. Yeah, I think that I did this, and I created an initializer function, and here it is. And I'm going to pass something to my constructor, right? That will be my data, and so this initializer, which is my in data, I'm going to put my data. That is nothing but my 5, which I'm going to pass. Okay, let me run this, for instance. Now, I was getting an error there. So here, what I'll do, I have to create this left part, right? So let me name this left, and initially that will be nothing. So I will be putting none as a keyword, and I will be creating a right of it. So again, there will be nothing. So I will use none here. No error. Okay, great. Let me select the Python compiler. So now, as my binary search tree class is created, let me see whether. Okay, I'm going to invoke this function with passing 5, and let me take this method actually, and let me name it as root. This will become me my object now. So now what happens here is you can see the code, right? Spell is alphabets are
Yes.
visible to you.
Mhm.
So what we did, we just created this box we have created. We have created what we did. We just created a box that is nothing but my node with having 5 here and none here. Okay, so that's all I created. To add some more values, I will be creating function. So what did I name it? Add child, right? So I'll be giving a function with name add child to it. We got emoji here. Child. And it will be also having some values, right? The child node will be having a value. Okay. So what I'll do, I'll call up my add child function using my this object root. So I got an access to my add child function now. Here I need to pass the data. So I will be passing to, let's see in the root node where it will reside. In the root node, it should reside to the left. Okay, means here I should get my 2 here. Okay. Okay. If I am going to use the root node here, if again I'm adding a child node, I need to pass the data. I'm going to pass 9 and it should reside here to the right side. Okay, but it is not going to happen automatically. Some kind of, we need to create a logic for that. So what we can do, there will also appear some case like this. Let's see, I can suppose I got a case here for case 3, no, case 4 itself only, where I shall I make it case 5. I have put 7, 5. Suppose I'm using whatever I've done there only. So I have created 5. To the left, I have created 2. I have added 2. To the right, I have added 9. Consider this thing. What if I got a fourth value that is also 5? What will happen to this? Where it will get inserted? We have not seen this thing, right?
It won't get inserted?
Exactly, it won't get inserted. At the very beginning, we have learned this because in binary search, we cannot add duplicate values, right? So I need to take care of that also. So if self dot data is equal to, double equal to, I'm putting the data. Suppose I'm passing, and, consider I'm passing from here with my root node add child, I'm passing 5 here. So that 5 will go here because I have invoked my add child function. It will go here and the previously added data will be checked with this. And if it is yes, it should not return anything. It just come out of that without doing anything. So what I can say, just let me put comment here, and 5 already exists. Node already exists. I can say node already exists. Okay, that is the case I'm handling with this line. Only with this line, I'm handling my duplicate values. I'm not telling my code that take duplicate values. Okay, just returning everything. Now going ahead here. Now, as I have checked for 5, that 5 is repeated value. Consider we have got only one node here, and I'm trying to insert 5 to it, adding 5 to it. So by this line of code, it will not going to add me that, right? Now I can add 2 to the left, I can add to 9 to the right, right? The bigger value to the left, sorry, smaller value to the left and bigger value to the right side. For that, I need to check. For that what I'm going to do. I need to check my data is less than the existing data, which is self.data, right? Self.data. So the new data, whatever the data 5 in previous case, I put 5. I was checking the 5 here, and previously there was 5, so we returned from there without doing anything. But if I am putting 2 here, so 2 will be my year. Is it 2 less than the 5? If yes, then I can say uh, insert it into the left subtree, right? So let me, again, I need to create subtree. There is another thing, right? It's actually need to work with recursion. Okay, let me see. Insert into left. I'm trying to create a left subtree here. Subtree. See what I'm into say here. Graphically, if you can see what is going to happen. I have already inserted 5. Okay, this is actually residing inside the variable called self dot data. Now I try to put a new node that is inside my variable only data. Understanding what I mean to say here?
Yes.
So as soon as it's we try to add this through that particular function at child. So these two values are going to be checked with this line. This line. Okay. Let me see. Have digital pen. We're not. Okay. See, here I have got 5. I have written something over the VS code. Is it visible?
Yes.
Okay. So this 5 is my first node created with this thing from here, this line. Okay. Now with this, suppose consider this one first here, where I'm inserting 5 here. Wait a minute. Okay. So when I'm trying to insert this here 5, so it will be passed to my this here. Okay, 5. Here is my 5, and here is already 5. This self data, this one is actually a self dot data, and I'm trying to pass a new 5 that is my data only. Okay, make sense?
Yes.
So what I said here, return, do nothing. So obviously there will be done, we will be doing nothing here. Now consider for this thing, if I am trying to,
So data is the root node?
yes, here every actually see whatever whenever you are adding something, it is considered to be root node when at every time, but its values keep on changing and based on the subtree. So here at the beginning, this was my root node 5,
Okay.
so which is already created here. Okay, so here is my 5. Now after this line, I am trying to add 2 here with this line using the function add child. So the 2 is passed. This 2 is going to be passed to here. 2 is going to pass to this function. Here I am going to get 2. That will be actually here 2. And self data is actually 5 here. Make sense now?
Okay. So what if you're trying to add 2 again?
That will happen. Just watch for this one whether it's working or not. We have
Okay.
not added till now for 2. See what I am doing here. Here I am passing my 2 from here to this function add child. Okay. Now we found that this is not equal, right? So the thing will happen here. Nothing will happen here. We'll go to this condition. At this condition, we have 2 at the data, we have 5 at self dot data. Now we are going to check whether it is less or greater. Getting my point here?
Yes.
If it is less, then I'm going to insert into the left subtree. Means I have to insert Here we by creating a node and then putting this value 2. Getting my point?
Yes.
If it is less, I need to create a node actually which will have left as none and which will have right as okay. See, actually what's happening here, again let me explain you because it's quite a minute thing happening here. See, when you are creating okay, see when this line is invoked, okay, when this line is executing, so what will happen? This will call my this class function, initializer function, with the value 5. With this 5 will be here, and this 5 will be stored to self.data, and self.data will create left with none and right with none. Means I have got created with a node which contain 5 as the self.data here, and I have none here as none and here as none. Make sense now?
Yes. Yes, it makes sense.
Okay. This line is executed. Now when I go to this line, when I'm calling up my add child function with value 2, this will going to actually call this one. Okay. So as it was add child is called here, I have data with value 2. Here you have value 2 here. And in self data, what do you have? What do you have in self data, Aisha?
Yes.
What do you, which value you have in self
5.
data? 5, exactly. Is 5 double equal to 2?
No.
Exactly, no. So we will be running into this map. My data is 2 here. My self data is 5 here. Is 2 less than 5?
If 2 is yes.
My 2 is actually less than 5, right? That means I have to create at this left side of my root node 5 where I will be creating another node as like this with 2, here is none, here is none. Getting my point?
Yes.
But to get this thing, to get this thing, again I need to use this thing, data and none, right? Even if I create a node somewhere here at the right side, again I need to create this, use this thing. So it's actually became a data type. It has become a data type. Okay. So let me explain you again, not again. What is happening? Okay. See what already we created here. We created node with value 5, and there is none, and there is none. Okay. So I need to make some changes in the code now. To create the subtree which I made here with the diagram, what I'm going to do, I'm going to just write this line self dot left dot. I need to call add child again inside this one. Means recursion. Add child with my data. Okay. but here is also some checking I need to do. A minute for that. See, this line, let me use something here. See, as we found, 2 is less than 5, I, I have to add something to the left, right? To adding something to the left, again, I need to call this function add child, and this is actually calling itself. Can you see?
Yes.
It's actually calling itself. So what I am doing, I am passing 2 inside here, and it will call itself. When it's calling itself again, it's going to check. When it's checking again, this line is going to repeat. Okay, before this line, I need to do something. Let me recode that. Okay, okay. Before that, what I'm going to do, I need to check if there exists or not. See, what will happen in this case? Let me take you here. See, what we have created 5. Now, either this will be the case, or either this will be the case where suppose we have uh, sorry, 4 on here. No. Either this will be the case or this will be the case where I'm trying to add 2 here. If I'm trying to add 2 in this case, I need to create a fresh node. Okay, and I have to check if it is less than 5. If it is less than 5, I will create a node to the left of it and put the value 2. Or if I am trying to add 2 in this case, so what I have to do, I have to visit this node. I have to check whether 5 is already having something over at the left side of the road, node or not. If there exists already a node, then I cannot do anything. Okay, so I need to again check. Again, I have to repeat the step again. What I have to do, I need to check again whether it is less than 4 or not. 2 is less than. If it is less than 4, then I can put here. Getting my point here? Why we have done recursion?
Yes.
See, once again, I'm telling you, just look what is happening. I have a case scenario 1 year. I have another scenario here where only one only root node is existing. In this case, root node is having something on the left and something in the right side also. When I'm trying to insert 2 here, I have to check whether 2 is less than 5 or not. If yes, and it should not have anything here. There should be nothing here, right? So I have to create a binary tree node. I have to create a node. Within that node, I have to put 2. Similarly, in this case, when I'm trying to add a child to 5, I have to visit 5 and to see is it less than 5. Yes, it is less than 5. But when I reach to the less than 5 for the left part, when I reach here, I did not got the space. Actually, there is already existing 4. Then again, I have to check whether my 2 is less than 4 or greater than 4. If it is less than 4, then I have to put this here to the left side. Make sense?
Yes.
Suppose I'm trying to add 3. Okay. So here in this case also I'm trying to add 3. There is no node here. I can create a node and I can place the node 3 here. But in this case, I have to visit the node. Okay, it is less than 5. I can put it on the left part. But when I reach left part, I got my node here. And which is, I need to check again, is 3 less than 4 or 5? If it is less than 3, so consider this is 3 and this is 4. If I am adding 4 here, I need, if it is greater than 4, then I need to add it to the right side here. Okay, means I have to also take into consideration putting right side value. Getting my point, understanding what I mean to say?
Yes.
If I want to add, suppose 6 in this case, again I have to need to check whether there is some, is it less than 5? My 6 is greater than 5 or less than 5? It is greater than 5. I need to go to the right and put it. Okay, but suppose I am inserting 4 here. I'm inserting 4. I have to visit 5. It is less than 5. Left part is already having a value. I need to check again before adding my value whether it is greater than 3 or less than 3. 4 is greater than 3. I need to put at the right side of the 3. So for that, I'm going to check here if myself dot left, if it is it if there is some value in the left part, if there is some value to left part, I need to create a subtree here, and here I can add the my this data. Okay, and if there is no subtree, suppose this conditions goes false, there is no subtree. This case is what? This case is actually this thing, case 2. Case 2. This 2 line is for case 2. Understanding, Aisha?
Yes.
What is happening here? It's checking whether 5 is having any other node inside it. So we got the node. What is there below to the left part of the 5? 3, right? So it will call again. This child will call again here. It will call itself. Again, it will check whether the number you have given is equal or not. If it is not equal, then it will check whether the number is less than that node or not. If it is less than, then it is going to add it. So in the else part, I need to add that particular thing. But when adding something, when adding a node, I need to create a binary tree structure. So self dot the left part equal to, I need to create an entire structure, means I need to use this line where instead of 5 it will be data. Okay, so let me explain you from this point of time. Consider this. See, here I got my 5 already inserted. Okay,
Yes.
so my 5 is also already inserted, and it is right now in which variable? It is in self dot data variable. Okay, now I'm trying, this line is done. When I'm trying to put this line 2, I need to check. So 2 is going to be passed here. Now 2 will be coming here. So 2 is here, and your self data is 5. 5 is double equal to 2. Yes or no?
No.
No. So this line is not going to run. We will be going for this line. Now data is 2, variable 2. Sorry, the variable data is having value 2, and self is having 5. 2 is less than 5.
Yes.
Okay, if self dot left, it's telling us it's already, there is some value already existing, means it's telling us, okay, there is something here, but for this case I don't have anything here. So this case is actually false. Where we will going to else part. There is no, this case is actually telling me there is a subtree. There is a subtree. Insert into a subtree. But in my case, there is no subtree. So we will be going to the else part. As since I don't have anything on the left side, what I'm going to do, I need to pass that to here. This will invoke my constructor, which will actually tell me that self data is equal to data self dot data equal to data and self dot left equal to none, self dot right equal to none. This is the code which we wrote above, right? So here 2 will be passed and this 2 will be given to this self 2. Okay, that means we will be creating an empty box here with 2 as self data. The new self data will be this thing. So this will be no longer self data now. And here will be having none and here will be having none. Make sense now?
Yes.
Any confusion?
No. So
What if we are going to add some new value? Okay, let me see. Suppose we want to add 1. Okay, so instead of 9 here, we have 1. Consider this thing. We have 1. So let's go and see. Again, this is going to call this function, right? So now we have 1 here. At this point of time, what is the value of self data? Aisha, what is the value of self data? You can see it. The new value inside the self data variable is 2. Getting?
Yes.
Now, or what we have passed from here, 1, which is inside data, this variable. Clear? Okay. Is this equal? No. Will it going to run this line? No. Let us go to this thing. Is 1 less than 2? Yes or no? Aisha?
Yes. Yes.
1 is less than 2. We will going to check. Oh, sorry. I made a mistake here. What will happen? I need to start from the beginning. Wait. When you're passing 1 from here, this function is going to run here. Okay. So this will start from this year as we have created in when we were practicing to create a tree. It will check from root node whether 1 is less than 5 or not. If it is less than 5, then only it will go to the left part here. If it is less than 2, then it will go to the left part of the 2. Understanding what I mean to say?
Yes. So the self dot data is 5.
Data, yes. When you're sending 1 year, so 1 will be checked with your 5 actually in the beginning, in the first iteration, when you're first telling it. Now, when it goes here, it is 1 year and it will be checked with 5 because we are checking with the root node. Now, for the 5, we will be checking whether 5 have a subtree or not. And we can see we have a subtree. 5 is already having something to the left. Understood? Suppose when
Yes.
we have 5 here and we have 2 here. 5 and we have 2 here. When you're trying to insert 1 in this tree, first you will visit 5, right? And it is 1 is less than 5, then you will go to left, but already left is having value 2, then you will go to left of 2. This is what we learned in the previous session, right?
Yes.
So then similar way, when one is called, sorry, when we are passing one, so the power of recursion is actually happening here. When you are passing one from here, one will go here. Your one will be getting checked with five. Is it equal? No, nothing will happen. Is one less than five? Yes, we are checking. We are right now in this point of time. Is it one less than five? Yes, we will visit going to subtree, and this is my subtree. Then we found that left tree exists, and since left tree exists, then what will happen? This recursion function will call itself. When it will call itself, it will pass one again, and this time the self data will check with two. This time it will be checking with two. Okay. So
Yes.
now is 2 equal to 1? We are checking here. Is my 1 is equal to 2? That 2 is equal to 1? No. Is my 1 less than 2? Yes. Is does this 2 have further subtree? No. This condition is false. It will go to else pass. Now it will create a new node which will be like this, where it will have 1 and it will have 9. And this is going to be connected here. So this is how it's actually working in as per the coding.
Oh,
Understanding?
yes.
Is everything clear
Yes.
or still some doubts?
Yes, it makes sense now, but I was thinking, so the self dot data is 5, right?
Yes.
Okay. So,
See, at every recursion, at the at very beginning, self dot data will be 5. Okay, and when we will be calling first time. But when the recursion occurs from here, when we are it's calling itself, that particular time self dot data will become 2 at this point of time.
oh, okay, then that makes sense.
Mhm. When suppose you are adding one more value here, consider you are adding 0. So again self dot data will be starting from 5, then recursion will occur, self dot data will become 2, recursion will occur, self dot data will become 1, and to the left part of 1 you will be adding 0. Make
Oh,
sense?
yeah.
Exactly. See, as we have seen, for 5 we have put 2. Sorry, what was that? Did I put it before? 3 suppose, and here 2. Okay. In similar context, I can go with like this, right? For right also, and the code will remain same. Just I need to change the variable name. Getting my point?
Yes.
So what I'm going to do, just I'm going to copy this code uh, from here. If not from here, because if my data is less than, then this is going to run. Okay, because I need to put this my number on the left side. If my number is greater, what happens? It means this condition goes wrong. So I have to skip all of this part. Okay.
Okay.
So here I will be having else part, which will be, sorry. So what will happen here? If my data is not less than my 5, root not, in case of 9, in case of 9, 9 is not less than 5. So all of this condition is going to be false, right? So it will
Yes.
be going for else part. That is means we will be handling right side of the node of 5. So I can copy this, I can paste this, and I need to check whether already on the right side of my 5 there is some subtree or not. If there's occur a subtree, then I need to apply a recursion. If there is no subtree, then I can go for creating a node. Then I just need to write here this right and this right. Okay. Make
Okay.
sense?
Yeah. So this is the same thing for the right. Okay.
Exactly. What we have done for the left here, we have checked whether the in this line we were checking whether the if the number 2 is less than 5. So we are checking whether there is existing subtree or not in this line. If there is existing subtree on the left side, then you need to do the recursion. You need to call itself again, check that particular node which is there at the left side. If there is nothing on the left side, directly you can put the node.
Okay.
Okay, and similarly we did this thing for right side. Suppose here if we are putting 9 and 9 is not less than 5, it is actually greater. So in 9 is not less than 5, it is actually greater. The condition will go false in this case. We will be running for the else part. And here if there is subtree in the right side, suppose there is subtree in the right side, then you will be creating, you will be using recursion to check for the nodes, right? Again, you will be, okay, wait, right. Okay. If there is exists some subtree on the right side of the 5, then I need to check again. I need to follow this entire process again. If no, just create a node, add that particular to the right side. Okay, I am getting some errors. Let me handle this. Hmm. If data is if the fraud is spelling any spelling mistake I'm committing here. Okay. Binary search tree, self node. Oh, sorry. What I did the mistake is I forgot putting colon. See, silly mistakes. I was wondering where I did this some coding mistake. Actually, I done mistakes of not putting a colon before the keywords. So here it's correct. Any further? Shooting out again. colon I put here. Button of slow. इफ के लिए डाल दिया हमने सेल्फ के लिए एल्स के लिए कोलन डाला है एल्स के लिए डाला है okay this is also handling okay everything seems correct spelling mistakes no okay Okay, let us not able to. Colons mistakes are not there now, but sorry. Some indentations mistakes
I
are there.
think there's not a colon on line 10.
Oh, so correct. Good, good, very good. So all the errors are there. We got rid of. Let us. What I put a breakpoint here, and let me debug this. Okay. See, here is my root. You can see root
Yes.
written here. If I click on that, see I got data 5. Okay.
Yes.
And this 5 is having left and right. Okay. Means this left and right data got here. And to the left, let's see if it has 2. See, it got 2. So at the left side, we got 2. And here in the right side, we got 9. See, I clicked on 9, right? Again, I'm showing you again. Let's see what's happening. See, I got the root here. Inside root, I have 5 here. Okay. And here there is left and right available. When I clicked on left part, I'm getting 2. Okay.
Yes.
If after clicking on right part, right side, I got 9 here. Means my structure is what I'm getting like this. 5 here, 2 here, and 9 here. Okay. So if I close this debugger, suppose, see, 5 we did not get 5 there. 5 wasn't inserted because it was same value. What if I put 6 and 7? And we'll keep this again. I need to run this again. The debugger. See, let's see what's happening here. So you got the root node. See, there is nothing on the left. You know? What was we should expect here? Our expected output should be 5 here, and we are inserting 5, 7, and 6. Again 5, right? So these are the thing. Root node is 5, 6, 7, and 5. So 5 will be here. Since 7 is bigger, it should come to the right part. Left will remain empty, nothing on the right left part. 6, so 6 shall come to the left of this. Whether I'm going right or wrong. Okay, okay, no. Here we have 6 and 7 here. Sorry. 7, then 6, then 5. Okay. So expectation is the 7 should come here. Again, I'm writing wrong. 6, 7, and 5. See here, 5, 6, 7, 5. Okay. I'm making a questions mistake. So and 6 will be here, then 7 is bigger than 6, then again 7 will be here, and we cannot insert 5. So it is on the right side of 5. 6 is on the right side of the 5, and 7 is also on the right side of the 5. This is the expected output, right?
Yes.
And there is nothing on the left part of the 5, and also there is nothing on the left part of the 6. So let's see whether we are getting expected result or not. See, we got the root node as root node data as 5, and there's nothing on the left, so I cannot click on that, but there is something there in the right side. Let's click on that, and I got 6, data is 6, getting 6 on the right side. Again, 6 is not having anything on the left, there is none mentioned here, you can see none, and there is something on the right side, there is something on the right side, and you can see on the right side there is 6, and to the right and left of the 7 I don't have anything, there is none and none. Okay, makes sense. Our code is
Yes.
going good.
Yes.
So here also you can say there is none here. So this is how our tree looks. So we created tree so far. Let me handle my digital pen. Okay, so I think it's taking lots of time. We have done creating. Can you say more few minutes? I think we can create an actually we saw in debugger. We need to see it properly. We need to print it, right? So I need few more minutes. Shall I continue?
Okay. Yes.
Okay, few more line of the code. Actually, what we did here, we just added directly individually. We are adding some files, right? Some nodes into the data. But what I'll be doing, I'll try to add some big nodes list. So let me create a list here. Let us name it as numbers. Okay, and we create a list. And let me put the same value which I gave you to solve. I think the number was 17, if I'm not wrong. What was that numbers? This one. 24, 1, 4, 1, B is 20, 20, 9, 23, 18, 24. Okay, we created this list, right? We created using this binary tree search tree. So what I've created a list. I put that into the number, and I would be telling I need to call a function here. Let me name this function as build tree, and let me pass this list to it. Okay. And let me pass it. And I need to create that particular function. So I would be creating function. My alphabets are visible. It's too small.
No, it's visible.
Okay. And what I'm going to do, I'm going to create a function there with the name build tree, and I will be collecting that number parameters argument into a parameter called elements. I'm changing the name of it. Let me put colon, otherwise I will create a mistakes. Errors. I will be printing that. What I'm going to do, I am going to let me print the element first in simple way. So here building with this elements. Let me put elements. So this will print me just actual question. Okay. Or the first root node I need to assign it. So just like before, and what I did, I need to create an object for that, right? For my class binary search tree node. and I will be giving the first index value, that is 17 to it. If you remember, we made 17-year root node, right? So here elements index value 0 should be assigned, right? So I need to give 0 here.
Oh, okay.
Make sense? What we did, we created this list, we named it as element, and the first index value, that is 0, we have made it as a root, and that's how we have created object for the class here. We have created class right here. So we create an object for this particular class, and we are passing this to my first constructor here. So what will happen here, 17 from here index value 0 will be passed to here, and the first node will be created using this. After that, I need to keep on adding my this value, right? I need to keep on adding 4, then 1, then 20. But before adding, I need to follow this thing. Before adding, I need to make sure uh, for 4, if it is less than 4, I should check. If it is less, then only I can put on the left side. If 1, if it is less than 17, you have to check whether there a subtree already exists. Then if it is exists, then I can go to the that particular tree. So this is already we did, right? So we need to handle this on our using something. It's an iterating work, right? I need to handle with follow for I in range as the first value I have already taken. I cannot. Then I need to calculate the. I need to start from index 1. Why? The reason why I have written 1 is here because I have to start from 4. Understood why did I write 1 here?
Yes.
Because 17 is already inserted as a root element from this, right? So I need to start from index 4. That's the reason I have. And how long I have to go? I need to go till the length of my list. So I will be passing elements to the, I will be calculating the length with the length function, and I will be stopping there. And in this particular function, I will be keep on adding my child node to the root. The same line actually, the root node which I've created in the last time, and single-handedly I was putting up single values here. I will, instead of data, we will be using list. Where I think I forgot colon again. So no errors. Okay, good. I've created a breakpoint here. Let me create a breakpoint here, and let me run this. See, now if we can see, just I have done this thing. This is the question which I have already got, right? Building a tree. This is the question. But if I want to see my tree properly, then I need to go to here. Is it not showing my previous output? Anything? I think it's showing me previous output. Okay, got it. I have redone this. See, the number elements I have got here. And see, 17, 4, 1, 27, 8. This is the index value actually. Where getting my left right values. Thinking to remember. Okay. Okay, I'm not printed actually. That's why that's the reason I cannot see here. I have not mentioned the print. So, okay, what I can do, I need to add one more thing here. I can do in order traversal here. And by using, I just, what I'll do, we can do it tomorrow. So tomorrow you have a class, right? It's getting too late for me here. It's 12:30.
Yeah. Tomorrow I have class.
So day after tomorrow, we will be doing traversal for this.
Okay.
Okay. So there I will be, the code will remain same. Code will remain same. Just what I need to do, I need to write code for in order, pre-order, and post-order. And from there, I will be showing you on the you will be getting the output in the this format, not this format, which we have done here in this way.
Oh, okay.
Okay.
Yes.
So here itself, you will be getting the output. So we need to write code for in order, then pre-order, then post-order, and that's again it is little confusing. We will do that again. Okay. So
Okay.
we'll continue on day after tomorrow, and day after tomorrow also I will be arranging your meeting with one of my developer to explain your requirement for project. Okay.
Okay. Thank you.
Okay. Okay.